In this problem, we're looking at this kite that's 817 meters in the air. We know the potential voltage difference, 175 e to the 6 volts up here, 0 down there. The radius of this kite string is this, and it's also been coated with a layer of H2O with a resistivity of the water, 168. And we're looking at the current through the H2O layer. We want to find the current. So we know that V equals IR. And so obviously we're going to put V over R to be able to solve for current. Well, the voltage, we know that. It's going to be 175 e to the 6 V. And then we just need to find R. Well, R is equal to resistance, or this is resistivity. Resistance and resistivity is kind of hard to remember which one is which. But anyway, the idea is that big R is equal to this thing that we know times L over A. So the length of this string is 817. So we can almost solve for R here. We're going to put 168 meters, and then we have L on top is 817. And now the area. Well, the area is going to be only of the water. So only this part. So that means that we need to take the big area minus the small area. Okay. So the big area is going to be, remember it's pi r squared for a circle. But we need to add up both of those radiuses. So it's like big R squared minus small r squared. And because we have a big R over there, let's try not to get confused. But the idea is that this one, let's do pi times the bigger R, which is going to be small plus big. It's going to 2.02 e to negative thirds meters plus this 0.512 e to negative third meters. And then we're going to subtract the other one, which is going to be just the regular 2.02 e to negative third meters. Keeping in mind, we want to kind of square both of these. So kind of like that. And that's going to be the area down here. It's kind of a big expression. But that's what's going to go down here. Area. And that is also going to go in there. So let's see if we can try to plug this into the calculator or something. Make it a little bit simpler. Well, we know we have this voltage thing at the top. So we've got okay, so we've basically got 175 on top, e to the 6. And then on the bottom side, kind of like I'm make a little parentheses. And then this, because on the bottom, we're going to have only the area. But on the top, we have 168 times 817. And then on the bottom, we have the area, which is pi times parentheses. And then we're looking at 2.02 to the negative third plus 0.512 to the negative third. And this kind of needs to be squared. So let's kind of keep track of that, because this is supposed to be squared. And then not only that, but we also, 0.02, let's try this first. Negative 3 squared. But we kind of want to make a big parentheses, because remember that over here we have a pi just sitting out in the middle of nowhere. We're going to kind of enclose the parentheses on the right side. Okay, and there we go. We got our answer. So I is equal to 9.3 e to the negative third amps. Sweet.